wake up. Wake him. This. Okay, we're talking about the summing point movement. So first one we already have seen that if we want to move a summing point after a block, then we need to multiply with that same gain. Same gain. G is called gain. Now if we want to move the summing point before a block here, so ahead means before. If we want to move the summing point before a block, so what do we need? We need to multiply with 1 by g. Not the g, 1 by g. Let's see here. Again, the same thing we will do. Suppose there is a gain and I have a summing point here. I have one input, there is another input, there is a gain, the summing point is here. First one. So what will be the output for this? Output R1G minus R2, right? This is the output for this. R1G minus R2. Now if I want to move this before, how it will look like? This summing point will be here. So here we have a summing point. Here there will be the gain. This plus minus R1, R2. There is a gain. Now what is the output? I move it before. So what is the output? This is G R1 minus R2. Is it same? Is it same? R1 G minus R2. G R1 minus R2. Is it same? No. So what do we need? Here. If we multiply with 1 by g, then look at the output here first. R1 minus R2 by g. Now if it goes there, R2 by g, we will have a g. Now this will give you GR1 minus R2, which is the same. That's why we need to multiply with 1 by g. If we move the summing point before a block, then we must need to multiply with 1 by g. Because of this. This is the proof. Alright, now next one is if we want to move a takeoff point after a block. Behind means after a block. Here, we just need to multiply with 1 by g. How and why? Look, here is an example. Here, we have a takeoff point. Right? This takeoff point will have the same output. If I consider this R and R, this takeoff point output is R. R. We will not consider the total output, we will consider the takeoff point output. R. Now, if I want to move this point here after, now it is moved here. We have an R. Here, we have an R. Now, what is the gain? What is the output of this point? GR. GR. But my output is R, not GR, right? So what do we need? we need to divide it by G. 1 by G here. 1 by G. So this will give you an output of R here. When you move a takeoff point, the takeoff point output has to be the same. We will not consider the total output, we will consider the takeoff point output. Takeoff point output. Here the takeoff point output is RG. But my output if this takeoff point is R on the R. So what do we need? We need to multiply with 1 by G. That's why we have a G, 1 by G, which will give you R. Because the takeoff point output must be the same. The takeoff point output, the output of the takeoff point, not the total point, takeoff point here, must be the same. The next one, if we want to move the takeoff point before a block, let's see what will happen. Suppose I have a takeoff point here. Now, here we have R. So this will give you a value GR. That is the takeoff point output. Now, if I want to move this before the block, suppose here we have R. I am considering there is no G before. There is no G before because it is just like that because it is R. Now, what is the takeoff point output here? Here, the output is R. But the output is not R, the output is GR. So what we need? We need to multiply the gain with the G. That's why we need to multiply with the gain with the G. It gives you a value of GR. That's why we are multiplying with G. Here we are dividing with G. So the takeoff point. These are the rules. Remember, you must need to remember the rule. While you solve the block diagram reduction, you must need to remember the rule. These are the very important 6 rules. We have 2 more rules. One is eliminating a feedback loop. If we have a feedback, suppose this, we have a feedback, then we can eliminate it by using the canonical form. This is G by 1 minus plus GH. Depends on whatever the value we have, we will use that sign. So, this block can be written as like this. So, here we have a feedback, this will be eliminated by using this G by 1 minus plus GH. So, we can eliminate that feedback loop, and if H equal to 1, H is equal to 1, the value is 1. So we define it just like this. If it is nothing, then it is H equal to 1. So if you put H equal to 1 here, we have 1 minus plus G. H equal to 1. That's the 7th rule. Now the last rule is if there are 2 summing points. Besides, with no gain. Here, there is no gain. So if there are 2 summing points, we can interchange this summing point without changing anything. We can, here, this one we can interchange the summing point. Now we have BA. Before it was AB. Now we can interchange it into interchange these 2 summing points without changing in signs and values. So if there is a block here, then you cannot do that. If there is no block, it is beside the summing points, neighbor summing point, then you can interchange. This is the last one. 8 rules we have seen. These are the very important rules. Now let's solve one problem. This is one first example we will solve 3 different problems. First problem. Now we have the root. This is the block diagram. So first of all, what actually you need? You need to find out this C by R. C by R, what is that? R is input and C is the output. You need to find out closed loop transfer function C by R. It is closed loop transfer function. So sometimes you will see it is mentioned CS by RS. Sometimes you will see only without S. Same. So how can you solve it? How can you reduce it? By using block diagram reduction technique. First of all, look at this. Here, G1, G4. So a G1, G4 are in cascade. So we will use first rule. What is the first rule? Combining the blocks in cascade in series, gain will multiply. So we will have G1, G2. That is the first rule. So if two blocks are in series, we will multiply the gain. We will combine that block here, the first one, and it will give you G1, G4 here. Second, combine all the parallel blocks. Here, we have a parallel block. We will use second rule. It will be added. Go back to the second rule. Combining all the blocks in parallel. So the gains will be added. G1, G2. So in our example, what is that? In our example, it is G2 and G3. So G2 plus G3. Now, redraw the block. Redraw the block. So here we have G1, G4. So this G1 and G4 will be so this G1, G4 is reduced to this, G2, G3 is reduced to this. You see, now our block is much more simpler. Now what we need, here look at this. This is look like this. It is feedback. This one is a feedback. So here, this is, we are considering this is G, this is H. Our G by 1 minus plus GH, our feedback equation is G by 1 minus plus GH. So here, here we will apply, we have the G value is G1, G2, G4, and H is H1. So we have positive sign here. So this is just negative. So we have G1, G4, 1 minus G1, G4, H1. Right? This is the rule, feedback rule. So this block is reduced to this. Now look at this. G1, G4, 1 minus G1, G4, H1. And now the block is look like this. It is more reduced. Now we have G1, G4, 1 minus G1, G4, H1. And then we have this G2 plus G3. G2 plus G3. Now both are equal in cascade. Cascade means multiply. So these two will multiply. These two will multiply and it will give you G1, G4. G1, G2, G3, 1 minus G1, G4, H1. So this is the standard form of feedback closed loop system. Look, standard form. What we have seen that before. summing point, we have open loop and feedback, and then we have the C. So we reduce the whole block diagram into this. Here. We just reduce the whole block diagram by using these rules into this. Now we have this R input, we have a summing point, this is G, this is H, we have C. Now what's the transfer function, closed loop transfer function? That is C by R. C by R. How do you find this C by R? This is your G. This is your H. We know the rule C by R is G by 1 plus GH, because we have minus, it will be plus. So we know the G, we know H. So you can find out the value how G1, G4, G2 plus G3 into 1 minus G1, G4, H1 into we have a value, this is G, 1 plus GH. So 1 plus GH, it is inside there will be this one, so we can write it 1 minus G1, G4, H1. And here, this one is this side, so it will be 1 plus, so here we will have 1 plus GH, so we will have 1 minus G1, G4, H1 plus G, that is G, G1, G4, H1 into H2, H2. So this 2 will be gone, and the total function will be like this. G1, G4, G2 plus G3, 1 minus G1, G4, H1 plus G1, G4, H1, H2. This is your transfer function, closed loop transfer function, C by RS, CS by RS. So you can write it in this way, and you can find out the closed loop transfer function. You see, by using the block diagram reduction technique, we don't need complicated equations. We don't need many complicated equations. We can find out the transfer function by just reducing the block diagram very easily. Let's do another one. Next example. Okay, in this example we have a bit complicated blocks. Bit complicated block, we have 2, 3 summing points, G1, G2, G3, and we have 2 feedback, H1 and H2. So how can we solve it? The first rule. What is the first rule? First of all, you need here. We don't have any cascade. We don't have any parallel. So we need to solve it by redrawing. Look here. This summing point. We need to move it before. If we move this summing point before, then this one and this one will be cascade. So if we move this summing point before this game, look, summing point before, what will you do? What will happen? We need to multiply with 1 by G. The game, same game. We need to multiply with the same game. Divide with the same game. Because this summing point we are moving it before. So we need to divide it by the game. So here we will do the same thing. So look look at this. Now the summing point we moved before the block and the gain was G1. So we are dividing it. Before it was H2. Now it is H2 by G1 because we need to divide with the gain because we moved the summing point. Now here we have G1 and G2. These two are what? These two are in series. So it will be multiplied. G1 and G2 will be multiplied. And now what will happening? What is happening? Now look at this. Still, we need to do some modifications because this is not this having the feedback because we have a node here. It is not a feedback. We have a node. So we cannot apply the feedback rule here. So now what do we do? We have two summing points here. So this summing point can be interchanged. These two summing points can be interchanged without changes any values. Why? Because the rule. The rule tells us swap two neighbors of the summing point AB can be swapped to BA. AB can be swapped to BA without changing anything, without changing any values. So these two will be can be interchanged if there is nothing between the 2 points. So here we have the rule. So we will apply that rule. Now here everything is the same. Now only the summing point here. These two summing points are interchanged. Now look at this. Now what? It looked like a feedback. It is a feedback. So we can apply the feedback. This is G. This is H. So here in this loop we will apply the feedback rule. G by 1 minus GH. G by 1 minus GH. So if we apply the rule, we have the G and H. So what will be the new block? It will be G1, G2, 1 minus G1, G2, H1. So this is the new block for that. So we eliminate the whole loop by this. We eliminated the whole loop by this. Alright, now let's see the next one. Here, this block and this block are in series. So what do you do? It will be multiplied. The blocks will be multiplied. Now it is eliminated. G1, G2, G3, 1 minus G1, G2 and so on. Now look at this. Now look at this. This is what? Another feedback. It is feedback because the output is feeding back to the input again. So here this is G, this is H. So now what we can do? We will apply the same G by 1 plus or minus, plus or minus. We have minus, so plus GH. So here we have G. G is G1, G2, G3. 1 minus G1, G2, H1. Okay. Now 1 plus GH. That is, we have this one 1 minus G1, G2, H1. So we will have 1 minus G1, G2, H1 plus we have G1, G2, G3, H what? H2 by G2, right? H2 by G1. x2 by g1. So here this is, we need to solve it before. So look at this, write it again. Here this is g, this is h. So g by 1 plus gh. So here we have g, g1, g2, g3. 1 minus g1, g2 is 1. 1 plus here g1, g2, g3 divided by 1 minus g1, g2, h1 into h we have h2 by g1. So here this g1 will be gone. So now you can solve that again. Now here write it down, g1, g2, g3, 1 minus g1, g2, h1. And here 1 plus g2, g3, h2, 1 minus g1, g2, h1. Okay. Now solve it again. Write it down, g1, g2, g3, 1 minus g1, g2, h1 into here this denominator will be here 1 plus g2, h1 and this term will be here 1 minus g1, g2, h1 plus g2, g3, h2. So this term will be gone, and we will have the total final value is g1, g2, g3, g1, g2, h1 plus g2, g3, h2. So that is your next block. It is not the final block, it is next block. That's how you solve. You need to solve it in this way in your final exam. There will be some questions like this. You need to solve the problems like this. And you need to show the block reduction. Not directly by solving like that. So the next block is like this: G1, G2, H1 and G2, G3, H2. Now this is your canonical form, but if you are asked to find out C by R or CS by RS, if in your question it is asked to find CS by RS like this, find CS by RS, then this is not your answer. What is your answer? You need to solve it again, right? What is that? CS by RS, the final equation. This is G and this is H. H is equal to what? 1. Right? H equal to 1. So you need to solve that here. I will write it down. Here this is G. So I am writing it down, CS by RS. G by 1 plus or minus here, plus or minus, plus, because I have an minus sign, plus G, H, here this H is equal to 1. So it is like just like this, 1 plus G. So now you solve that. What is G? G is this G1, G2, G3. 1 minus G1 G2 H1 plus G2 G3 H2, and then here 1 plus G. So write it down again. G1 G2 G3. Then 1 minus G1 G2 H1 plus G2 G3 H2. Okay, now solve that again here and doing it here. 1 minus G1 G2 H1 plus G2 G3 H2 into, it will go up, the denominator will go up, so 1 minus G1 G2 H1 plus G2 G3 H2, and this one will come here, so we will have 1 minus G1 G2 H1 plus G2 G3 H2 plus this G1 G2 G3. So this value and this value will be gone. So the final answer will be this G1 G2 G3, and this 1 plus G1 G2 H1 plus G2 G3 H2 plus G1 G2 G3. So this is your final answer. That is your final answer. For if you are asked find CS by RS, find CS by RS, then this is your answer, not this. If you do this, you will not get the full mark. Then if you need to find that, then you will get the full mark. Alright. Try to practice it at home because it is much more difficult. You need to try to practice it more and more because there are many G1, G2, G3, H1, H2, many. So write it properly. Now, so far what we have seen, it is one input. What is that? That is R, only one input. If we have more than one input, two inputs, like this, here, x1, x2, two inputs. Here, there is only one input. So far we have seen only one input. If we have more than one input, two inputs, how do you solve it? Suppose in this system we have multiple inputs, and these inputs are, here we have one input R, another input U, two inputs. If there are two inputs, how can we reduce the block diagram? We will use superposition method. What is the superposition method? Superposition method is a method, first we consider one input 0, we will solve by another one, then we consider that input is 0 and we will solve that another one, the one we considered 0 before. So here there are two steps, then we add both. First step, put u equal to 0, considering one input is 0 here. If we consider one input is 0, then how the block diagram will look like? Look, we have R, it will be the same, summing point, it will be the same, we have a gain, there will be a gain. Now here, no input, because we are considering u equal to 0 first. So no input, another input is considered 0. So these two will have like this. Now this G1 and G2 in cascade. That means it will be multiplied. And there is an output. Because we are considering R input, that's why the corresponding output is CR. So here we need to find out the output, total output C. So first of all we need to find out here. How do we find this here? We already know the transfer function CR by R, output by input, that is the closed loop transfer function. So this is G and H is equal to 1 here. We don't have, so H is equal to 1. So we can write it G by 1 plus G. 1 plus G because we have a minus sign. So it is 1 plus G. So here we have G1. G is G1, G2, 1 plus G1, G2. So here we have an R. We need to find out this C. Not CR by C by RA. So here we can write it like this: CR is equal to this into R. For the first one. Now, second one. Now we consider R equal to 0. Look, here, this one. If we consider this R equal to 0, here, no R. So we have U, because we are considering R equal to 0. So there is no R. So it is just like this. It is just like this. Now here, look at this. We have a summing point, and we can redraw. We can draw it in this way. We have U. These two summing point, we have G1, G1. Here we have a negative minus 1. So why it is a negative minus 1? Look at this. I have minus sign here. Why do we consider R equal to 0? There is a minus sign, minus. That's why there is a minus 1. So this minus 1, we need to consider that. And we can redraw this. Now this minus 1 will go through here again, and it will have a summing point minus. This minus 1, because of that, the summing point. Here it will have a minus. Now look at this. Here, this equation, this block diagram, we just redraw it. Now it is simplified. Now we have a simplified block diagram. This is G, and this is H, because this is feedback. So we already know about the equation. What is the equation? Now we are finding Cu by R. Cu by U, not R, because it is the input is U now. Cu by U. So here we have G by 1 plus GH. So we have G by 1 plus GH, and G value is G2, and 1 plus G1, G2. But now we don't need to find out this transfer function. We need to find out this Cu. So we can write it Cu is equal to G2 by 1 plus G1, G2 into U. Now we have C out and CR, CU and CR. So the total output C is equal to CR plus CU. That is the superposition method. In the superposition method, first we consider 1, 0, 1 input is 0. Then we find out another one in output. Then we consider that the first one is 0, and we find out the second output. And later we combine both output. We combine both output, CR and CU. So the total output is equal to CR plus CU, and which will give you the value. CR is here, it is G1, G2, 1 plus G1, G2 into R. So G1, G2, 1 plus G1, G2 into R, and here we have G2 divided by 1 plus G1 G2 here, G2 by 1 plus G1 G2 into U. So here this we have some this and this and this are common, so we can just write it in this format. G2 1 plus G1 G2. Then we have this G1R. We just take in common and this. That's why this means G1R plus U. This is for 2 inputs. If you have 3 inputs, suppose here, if there is one more input for Z, suppose Z, then you also need to do the same for the 3 multiple inputs. So the output will be CR, CU plus CZ. So consider 1, 2 is 0. First you consider this 2 is 0. Then you find out CR. Then you consider R and this 0. Then you find out this. Then later on you consider R and U 0. Then you find out this. So in this format you can, by using, this is the superposition method. By using superposition method, if there are multiple inputs, we can reduce the block diagram and we can find out the transfer function, and also we can find out the corresponding output of the total system, the whole system. That is all about block diagram reduction for this class. In the next class, we will talk about one more important topic, that is called signal flow. Signal flow graph. You have it in your book. And signal flow. I will upload the PPT before the class. Remember, I always upload the PPT before the class so that you can read it. Read the PPT. Read the PPT. I will always upload the before the class, before coming to the class. Read the PPT so that you can understand more in the class.